Okay, good afternoon, everyone. Dr. Jensen here. Today we're going to look at making solutions. So first, we'll take a look at some of the basic math for doing a dilution. Okay, solutions are made generally two different ways. One is via dilution, or if we have a solid starting product. In this case, we're going to be looking at diluting. Our solution we're going to make starts from a 14.8 molar ammonia. So this is very concentrated. And we want to make 500 milliliters of a 2.5 molar solution. Generally, when we are making solutions, we know the quantity and quality of the solution that we want to make. Okay, and so we are generally given a starting concentrated stock solution as well. Dilutions follow the equation. M1V1 equals M2V2. Okay, generally doesn't matter which side you set up to be which, but in this case, I will start with the 14.8 molar as my concentrated side. And what I want to know is how much of it do I need to measure out in order to make a 2.5 molar solution that is 500 milliliters. Okay, you can use milliliters as long as the end result here, what we were expecting to get out, is also milliliters. So here it is very simple, simplistic multiply and divide. So the volume one is 84 milliliters. There's some decimal places in here. You could be like 84.5, depending on which the sig figs are that you want to go with. Okay, so then what we're going to do is take this same thing and come over to the simulator. And we want to replicate. This over here. Okay, so when you come into the simulator, all right, or you're working in the lab, we're going to need some basic glassware. Okay, so the stock solutions are all relatively concentrated. There's a variety of different stock solutions here, but we want to pull out the ammonia. Okay, we're going to be working from that. If we're doing glassware or making solutions, we have volumetric flasks. So we have everything from 100 down to up to a liter, but we want to take the 500 milliliter flask out. And then if we're measuring things out as well, we also want to use a graduated cylinder. The largest one here is a 50 milliliter graduated cylinder. Okay, so I need to measure out 84 milliliters of this and get it into here. Okay, so we're going to start with our measuring out the 50 milliliters. Okay, so again, this is kind of depends on what you bring into what here. So if we do this, now we want to transfer this to our other flask. So we just had 50 milliliters in there to start with. Okay, but we'll also notice our volumetric flask now has 50 milliliters in it. And so now we're going to measure out the remaining 34 milliliters. Okay, and you'll see the bottom of the meniscus show up there. And then we can transfer the remaining 34 milliliters into our flask. So now we have our flask with 84 milliliters of the ammonia. And then we want to dilute. So our solution, so there's some distilled water. So we want to fill our flask up to the line. So in this case, since we already have 84 milliliters in there, we need another 416 milliliters. Again, if you're doing this in the lab though, you wouldn't have to measure out the water in its volume. We would dispense it based on where it hits the bottom, the top of the line, or the bottom of the meniscus hits the line. And then from that, we would have essentially our solution we're trying to make. And so if we look at the information pane, you can see here the ammonia is 2.47 molar. And so that's really what we were looking for. Again, in the lab, it's not going to be perfect. If you were measuring out a solid sample, you wouldn't sit there and take grain by grain trying to get exactly 25.0000 grams, just like we wouldn't sit here and measure out exactly the volume down to 2 or 3 decimal places in order to make our solution. Whatever we're going to use this solution for, the chemistry works, whether it's 2.5 or 2 or 5. We just want to make sure we record down what is the concentration of the solution that we are actually using, because then we can use that for the remaining math. The math itself works itself out down the road. Okay, so in making any of our stock solutions, we generally know the concentration that we're working from. We generally know what size of flask we want to use, and we generally know what concentration we want to get to. Okay, and so that applies to most any of these dilution problems, and so we can use the same methodology to make any other number of solutions. We have a variety of round bottom flasks. You want to measure out the concentrated solution. That's generally going to be the focus of our questions. Is going to be how much of the concentrated solution do we need in order to make X concentration. Okay, and that's it for this video. And we'll be back with another video later for how do we do calculations for making solutions starting from a solid.